So here we have the direct formula of integration, which states that integration of f of x the whole raised to n into f dash of x is nothing but f of x the whole raised to n plus 1 upon n plus 1. In our case, n is minus 2. So this integration will be f of r. F of r is 1 plus r square. So 1 plus r square the whole raised to n plus 1. In our case, n is minus 2. So minus 2 plus 1 is nothing but minus 1 upon n plus 1, that is minus 1. This half will remain as it is into d theta. And then we apply the limits of the integration, where r is going from 0 to r is going from root of cos 2 theta. So we will take this half and minus 1 outside the integration. We will get I equal to minus half integration of theta equal to minus pi by 4 to theta equal to pi by 4. Now 1 plus r square the whole raised to minus 1 is nothing but 1 upon 1 plus r square, and here we are applying the limits r equal to 0 and r equal to root of cos 2 theta. So this term will be upper limit minus lower limit. Upper limit, when we put r equal to root of cos 2 theta, so r square will be cos 2 theta. So 1 upon 1 plus cos 2 theta minus r equal to 0, when we put here we get 1. So here in the bracket we have 1 upon 1 plus cos 2 theta minus 1 into d theta. So now consider this integration. So here we are going to substitute this term. We know that cos 2 theta is nothing but 2 cos square theta minus 1. So cos 2 theta plus 1 is nothing but 2 cos square theta. So this term will be replaced by 2 cos square theta. So here we have 1 upon 2 cos square theta minus 1 d theta, and this term will remain as it is. So I will become 1 upon cos theta is sec theta. So 1 upon cos square theta will be sec square theta, and half will remain as it is minus 1 d theta. And here we have integration of minus pi by 4 to pi by 4, and minus half will remain as it is. Now if you see here, we have the limits of integration going from theta equal to minus pi by 4 to theta equal to pi by 4. But we cannot integrate when we have the limits going from minus a to plus a, and if the function is symmetric about x-axis or y-axis. As you can see in this equation, this loop is symmetric about x-axis and y-axis. This means that the area covered by the loop in the upper half is equivalent to lower half. So this up area is positive and this part is negative. When we add these two terms, we get area equal to 0. So what we have to do, but we know that the area is not 0. So when we have this situation, we first check whether our this function is even function or not, because when f of x is even function, then we can write this integration as 2 times integration of 0 to a. Okay, because the area covered is symmetric about the axis, so we can write 2 times 0 to a f of x dx only for even function. When the function is odd, this integration will become 0. So now we will replace theta by minus theta. So sec square minus theta is sec theta, so this function is even. And remember, constant are always even function. Mind my words, I am not saying it is a even or odd number. Even function and numbers are very different things. Okay, so my 1 is also a even function. Okay, so whenever we have even function, we can write minus half. We can replace this integration by 2 into integration of 0 to pi by 4, half sec square theta minus 1 into d theta. This 2 and this 2 will get cancelled, so we have minus 1. What is integration of sec square theta? Integration of sec square theta is tan theta, and this 2 upon 2 minus, what is integration of 1 d theta? Integration of 1 d theta is nothing but theta, and here we apply the limits of integration. So this will be equal to upper limit minus lower limit. When we put theta equal to pi by 4, what is tan pi by 4? Tan pi by 4 is 1, so it will be half minus pi by 4 when we put theta equal to pi by 4. When we put theta equal to 0, it will be 0 minus 0. It is nothing but half minus pi by 4. If we take the LCM and this minus sign here, so minus of this term and minus of this term, so we get pi by 4 minus half. When we take the LCM, we get pi minus 2 by 4. So this is our final answer, and this is how we solve the problem on type 2b, that is integration over a given area using polar coordinates. So in this we learned that whenever we have the complex curve equation, that is as you can see here, this is a very complex equation, then we will convert our Cartesian coordinates to polar coordinates, and now you can see that our integration has become a very simple procedure to solve. So this is how we solve the problem on type 2b. More such problems we will see in our next video, so stay tuned for our future lectures.